All right, so in this video, we're going to look at comparing what method we would use to solve three different systems. So one thing that I'm going to look at is if it's going to be easy for me to graph. So the things that I need to look at are if it's in standard form, can I find the x and y intercepts quickly, and will they be whole number solutions? If not, then I need to look at, could I quickly get one of my equations in x equals or y equals and isolate a variable? And if neither of those things are going to be super quick and easy, then I'm going to resort to using elimination. So in this first one, I'm not set up to easily graph this because if you look at this second equation, if I try to find x and y intercepts, I'm going to get fractions. So graphing is not an option for this one. It will not be pretty. And actually, I'm going to put no here instead. Not going to graph. It's going to be gross. So if I'm on this sheet, it says that we're only going to use each method one time. So now I have to think if I'm going to do elimination or if I'm going to do substitution. Well, I notice here that the coefficient for x and the coefficient for y are 1. So I would say this would be a really good one for substitution because I can really quickly get this first equation as x equals. So if I add y to the other side, I'll have y minus 2. And now I'm set up to do a really quick substitution into that second equation. So I'm not going to do elimination. I'm going to do substitution on this first one. So I have 7 times y minus 2, because that's what we know what x is from our first equation, plus 2y equals negative 5. So I'm going to distribute that 7. So I'll have 7y minus 14 plus 2y equals negative 5. So I'm going to combine my like terms of 7y and 2y, and that's going to give me 9y. And I'm also going to add 14 to both sides, which is going to leave me with 9. So I know that my y value is equal to 1. So now, because I know y and I have x equals here, I'm going to go ahead and just substitute y equals 1 into this first equation that we manipulated. 1 minus 2 gives me negative 1. So my solution is negative 1, positive 1. All right. So substitution is off the board now. Bye-bye. So now I'm going to actually look at both of these and see which one would be the better choice. So if you look here, thinking about graphing, substitution's off my list. So thinking about graphing, that's going to make a fraction for x and y. That's going to make a fraction for x and y. So it sounds like graphing is a really bad choice for system B. But if I look at this one, I can really quickly get this in y equals. It would be y equals negative 2x plus 4. And this one, I would get fractions if I tried to find the x and y intercepts, but if I got this in slope-intercept form, it wouldn't be that awful to graph. I would have a whole number for my y-intercept, and then my fraction would be my slope, and that we can deal with. So I'm going to subtract 4x. So I have negative 3y equals negative 4x plus 18 and divide by negative 3. So I'll have y equals 4/3 x. I really didn't leave myself enough room. Y equals 4/3 x minus 6. All right, so I'm gonna take we're gonna graph these now. This should not be the hard part. All right, so let's start with negative 2x plus 4. So I'm gonna go up to 4. There's that. And I'm going to go down 2 and over 1, or up 2 and over 1. Oh, Lord have mercy. The slope is negative, Miss Hall. Go the other way. Ay, ay, ay. Make sure that you don't do what I just did, and pay attention when you're graphing to if the slope is positive or negative. If the slope is negative, it has to be a decreasing line going from left to right. Make sure you pay attention to your signs, people. Signs are very important. All right, my other one, I'm going to go down to negative 6. And I'm going to go up 4. 1, 2, 3, 4 over 3. Oh, look, there's my point. So that is 1, 2, 3, negative 2. All right. Last but not least, so that was graphing here. So we're going to do elimination for this one. Now, this one is yucky because it can't be graphed easily. Let me zoom in a little bit. There we go. Can't be graphed easily. Not super easy for substitution. So we have to do elimination in this case. Unfortunately, because we're not having a graphing calculator in this case, graphing is off the table. Substitution, we would have fractions, and nobody wants to do that. So I have to actually manipulate both equations in this case. So at this point, it's up to you if you want to eliminate the x's or the y's. If I'm thinking about the least common multiple, between 8 and 3, it's 24. Between 5 and 4, it's 20. So personally, I'm gonna choose to eliminate the y's. So I'm aiming to get y to be 20 for both of these as my coefficient. So I need to multiply the first one by 4, and I need to multiply the second one by 5. One of them has to be negative. It does not matter if it's the first or the second, but one of them has to be negative so that my y's eliminate and create 0. So 8 times 4 is 32x plus 20y equals, and then I have to do 13 times 4. Well, 4 times 10 is 40. 4 times 3 is 12. So if I add 40 and 12, that gives me 52. And then 5 times 3, negative 5 times 3x gives me negative 15x minus 20y equals negative 50. All right. 32 minus 15 is going to leave me with 17x. 50 and 52 gives me negative 102. So now I have to think, how many 17s will it take to get to 102? Well, it takes me almost 6 15s to get to 100, give or take a little bit. So I'm going to try and do 6 first. So I'm going to do 10 times 6, and I'm going to do 7 times 6, and I'm going to see what that gets me. So 10 times 6 gets me 60. 7 times 6 gets me 42. And that actually is 102. So this is going to be negative 6. And it's negative because 102 is negative here. And again, that was just a guess and check. I tried 6 because I know it takes me about 6 15s to get close to 100. So I would try 6 then for 17. All right, so now I know that x is negative 6. I can choose either one. I'm going to choose the second one just because the coefficients are smaller. So 3 times negative 6 gives me negative 18. Adding 18 to the other side gives me that 4y is 28. Dividing that by 4 on both sides tells me that y is 7. So this solution is negative 6, 7. So again, out of this, we are looking first at graphing. Can I quickly get into slope-intercept form where I have whole number y-intercepts, or would my standard form quickly lend itself to whole number x and y-intercepts? If not, then I look to see if I can quickly isolate x or y. If I can, and there's not going to be any gross fractions or anything like that, then I'm going to do substitution. If graphing and substitution fail or are not easy to do, then I'm going to do elimination, and sometimes that will require that we manipulate both equations.